Hey, Renaya. How are you? Good to see you. Hey, Christian. Happy Monday. We got back from Thanksgiving, probably more rested, I hope. I'm good too. Yeah, more rested. Excellent. So now we have the holidays upon us. Christmas is coming and it's just around the corner. Now I'm panicked. Got the Christmas tree for sure. So, hey, Madison. Good to see you. And Christian and Kalia. Good to see you, Kalia. Let me do this. Make this a little bigger. There we go. No, I was late. I had some people that were having some difficulty in class, so I came in 2:07, unfortunately, when I got here. Okay, so um, here is what we're going to be doing today. So if you can take a look at the assignments page here. All right. Okay, so let me show you from the module point of view. All right, so what we're talking about today is we're talking about week 15. So we have 3 weeks left, January 11th. Okay, so you can see week 15 is about counting atoms in a chemical formula, right? So this is where people have some struggles and they struggle with understanding what a chemical formula looks like. And so we're going to try to do this in terms of a some pictures. Okay, I'm going to show you some things. Hopefully this makes sense because I usually what we do is we have models that we can use, but we have to use pictures. So graphic organizers here, right? Work assignment number one, assignment two, and the quiz. So that's what we have so far. All right. Um, if we look at the module here, we have, all right, so we have the Ed puzzle. I think I've got this figured out. What types of matter, elements, compounds, and mixtures. So there is a bonus assignment here. Assignment one, okay, because on Thursday is what I need. So we don't have live sessions there. We have some help sessions at 12 and 3, right? So we don't have any live sessions there. So you can see that everything's kind of shoved closer here. So assignment one should be done today. It's due on by Friday. There's an exit quiz today, so I would like you to do that to give me information about what we went over today. There are bonus assignments, a couple bonus assignments tomorrow. Okay. Then we'll be talking about counting atoms. So we'll be talking about counting atoms tomorrow, and then there's an exit quiz for that. And then Friday we'll be doing the quiz. So we have 3 days of assignment of going over slides and so forth, and then 3 assignments here. So bonus on you as your own pace, but they do bonuses are due by exit quiz. Let's see, by December 1st is a bonus. December 8th for the CAMI, December 1st for the Ed puzzle. So they don't last long for bonuses. I know it tells you that you're missing assignments, but I apologize. You don't have to do them if you don't want to. Okay, so what we're going to be doing today, okay, we're going to be taking a look at chemical reactions, the beginning of chemical reactions. All right, and chemical reactions um, are something that we're going to be doing. Unfortunately, most of the time we're going to be doing this during testing, which is unfortunate. Okay, so in a chemical reaction, uh, the types of events in the universe, the chemical reactions that plants grow, produce fruit, and become compost for new plants. It's because chemical reactions that human beings and all other animals reproduce, digest, grow, and heal and think. We'll be doing how we're going to do this is we're going to look at the taking lecture notes, going to watch the lecture. We have a PhET lab on molecules and some Edpuzzle assignments. So these will strengthen your information. So what we need to know is how to differentiate elements, molecules, and compounds. So we're going to do that. We're going to first take a look at pictures here, right? Then we can tell the difference between mixtures and pure substances. Then we're going to look into chemical formulas and explain the difference between subscripts and coefficients. And then we're going to count atoms, which is part of the idea of conservation of matter. What goes in is the same as what goes out. We kind of sometimes think that what goes in does not necessarily come out the same, but this is this idea of conservation of matter. All right, so let's take a look at this. Okay, so I'm going to show you some things that what I'm talking about. So let's say gold is an element of gold elements. Elements with gold elements in it will look something like this. Okay, so we in person we'll have a little ball that we use. Okay, and elements are one thing. Okay, and so let's say it's yellow. Okay, this, let's see if I can show you this. This would be a different one. So like, let's say this black ball, it represents the carbon. The yellow ball represents the gold. Okay, sometimes atoms like this come in elemental form, like one atom. Okay, sometimes gold comes as a gold atom, and sometimes carbon comes as a carbon atom, one carbon atom. Okay, but sometimes, like oxygen, it comes in a group. Okay, so this is two of the same color but bonded together. So those are called molecules. It's still an element because they're the same color connected to each other. So, all right, so this is a different color. Green represents a different element altogether, and this is what we call a single atom, right? Sometimes elements can exist as single atoms, and sometimes they need to be connected to one another, but they're all the same color. So you can see in our diagram here, the green is represented as a sphere. It's the same color and size. Okay, size makes a difference, color makes a difference. All right, same size and color. So again, we're trying to represent something that we can't see in real life, and we're going to use a simple model like you do with Legos and so forth. And that's what we do. So here is a molecule, two of the same colors, just bonded together. So this is an oxygen, red for oxygen, right? And here is, okay, a white for hydrogen. So here is a red molecule, a white atom. Okay, so let me ask you this question here. See if we are on the same page here. I'm going to ask a poll question. Okay. Which is the molecule and so A, the white, or B, the red? So let's try a poll here. All right, so A and B. Okay, let's do this. start a poll. I'll show it to you. Here is the two reds. Is that a molecule? Okay, which is the molecule, or is it the white? The red or the white? Okay, right? This is oxygen. This is hydrogen. Okay, red or the white? Hey, Bradley. Hey, Donovan, Jasmine. Thanks for getting there, guys. Phoebe, Kamaya. We can get some more votes. The red one or the white one? Hey, Donovan. The red or the white? Okay. All right, so the molecule. Okay, so most of you guys got that right. The red one is the molecule, okay, and the white one is the atom. Okay, so single color, right? So here would be two atoms of two different elements. So let's say this was gold and this was hydrogen, two atoms. So they're single. They're not connected in any way, right? Right? So those are atoms. Okay, so let's take a quick look at LEAP. Okay, so now we're talking about compounds, okay? So here is a compound of water, okay? So you'll notice that if I hold it up there, it's two whites, upside down, I'll put it upside down. Okay, two whites for the hydrogen and red for the oxygen. Now, that's how my model comes. Now, what they're looking at is green in this particular case. They're saying, and how we can tell this is oxygen, because I got two H's and one O. So this is the O. It's the only one that has one. And these are the hydrogens right here, right? This one and this one. But also notice they're pink. So that means these are hydrogens. So there are three of those, 1, 2, and 3. And this is a different color, larger ball. So that's your N. Okay. So colors make a difference. Now here, green again. This means this is oxygen and this is oxygen just because there are two of those, and also it represents the same oxygen in the water above. And then this kind of gray one is carbon. CO2. Here is another hydrogen, represents here and here. And these are the oxygens. So two oxygens, H2O2. So compounds are made of two or more different elements. Okay, notice that we have two different elements here. Here we have two different elements. Same way here, we have carbon and hydrogen. So they're all two. We could make them longer, but certainly this is probably the smallest unit, 2. Okay. And they react together to form a new substance. Remember that hydrogen is a gas, right? And oxygen is a gas. So hydrogen and oxygen are, you breathe oxygen, hydrogen is flammable, but together becomes water. So that's what they mean by react. Totally different than what we had before. Now, a mixture contains elements that are compounds and elements chemically that are not chemically bonded. So basically what we're showing here is, so in this particular case, if you can see this, and I'll show you my picture here. So I've got a water molecule, right? And with like a green sodium atom. Okay, so they are separate. They're not together. They're not bonded together. They can be separated. And again, in this particular case, so if this is Na, sodium, this is also Na because it's blue. It's the same if I give this a designation of Na, and this Cl, right? So we've got H2O compound. We got a compound here, right? And then we got some single atoms, single elements, single E, big E for elements. They're not bonded together because if I boil the water away, I'll have the sodium and the chlorine separate. So mixture. So let's take a look at this one. So let me go back and let's look at the definitions. Elements, a substance that cannot be broken down any simpler substance by chemical means. An element is composed of atoms that have the same atomic number. Remember, atomic number is the number of protons in its nucleus. Okay, so we can have atoms that are separate or together. Again, it can be in twos, but it can be more than that. But a compound is two or more different, and we do that by having different colors and different sizes to represent different elements. So we're kind of trying to look at this as a picture. And they form a new substance. So they're no longer an element. They are not on the periodic table. They form a compound, which is a combination of more than one element. Then we have mixtures, which contain elements and compounds, and that they can be separated. Okay. So for number 1, number 2, and number 3. Okay. So let's figure out which one goes in number 1. So it's one of these 3: compounds, mixture, or element. Okay, so let's get a poll question here. All right. My poll question would be, start a poll. First, which is number 1? Number 1. Okay, is it A, compound, B, element, or C, mixture? So trying to figure out what we just read. What did we get? A, B, or C? So let's get rid of the D. What would you say this was? A blank is composed of atoms that have the same blank. So what is it? Compound, element, or mixture? Right? So compound, element, or mixture. Thanks, Kamaya. Anybody else? You have a really small class today. Okay. Thanks, Bradley. Thanks, Saria. Thanks, Donovan. Kalia. Hey, okay. Hey, Jeremy, I didn't see you come in. Hey, good morning or good afternoon. Hey, Jasmine, thanks so much. Okay. Anybody else want to get in there? Shayana, want to get in there? Okay. All right. Publish the poll. Let's see. We've got element. Okay. Anybody want to write in the word element in there, or anybody willing to participate for element in there? I'll give you the all right. Public chat. Element. Nope. Okay. So not any takers here. Okay. So this is, let me get the medium here. Medium. So this is an element. Element. M-E. Element. See if I can get rid of this thing. Nope. Just keeps wanting to pop up here. All right. So element is composed of two or more of atoms that have the same, okay, atomic number. I'm afraid you guys are asleep on me. And that have the same number of protons in their nucleus. Okay, so we're getting closer to figure out what the other one is in here. All right, all of the atoms are the same. So we use the same color, same for the same size and so forth, protons and so forth. Okay, so 2 and 3. Let's do another poll here. Start another poll. All right, so what are we going to put in next? Start a poll. So what is number 2? Number 2. Is it a a compound? Okay, let's do this again. Compound. I just typed over there, didn't I? Delete. Compound. Or a mixture, B. All right, so let's do A and B. See what you got there, A and B. What do we got? Compound or mixture? Blank are made of blank or more elements with chemically. So what do we got? Compound or mixture? Got 50-50 in there. Thanks, Jeremy. Thanks, Donovan. Thanks, Kamaya. Okay. Thanks, Bradley. Daria. So it looks like we've got more of you saying compound, and that's true. This is compound. Let me put down here nucleus. And then this one here is going to be compound. All right, so compound is what we talk about having 2 or more different elements, 2 or more, TWO, different elements. Okay, no longer on the periodic table. We use the elements from the periodic table and they react together, And they form something totally new. Get rid of this. All right, so we got one thing left. Okay, a chemical blank. Anybody want to write in what that last word in there is? Anybody want some whiteboard time? Whiteboard time, anybody? How about Kamaya, would you like to write down mixture in that one last one there for me? All right, here give you whiteboard access. Yep, for it says number 3, mixture. Great. All right, and then you can just kind of drag it a little bit bigger and you're all set. Right, and they are not, so could you type in not chemically bonded in the second space there? Just not. Great. Okay. All right, so let's see how we did here. So an element is composed of atoms that have the same atomic number. That is, each atom has the same number of protons in its nucleus as all atoms are of that element. Compounds have 2 or more elements which chemically react together to form a new substance like hydrogen, oxygen. A chemical mixture contains elements that are are elements and or compounds that do not chemically mix, chemically bonded. Okay, so here we go. We're talking about the atoms and the molecules again. They're represented as spheres, chemically joined. That's the molecule. Okay, right? Mixtures, on the other hand, now notice the different sizes in here. This, let's say this is a nitrogen, and because of the different color and size, let's say this one is um, like a sulfur. Okay, so you can see that this one is a sulfur. If I said it was a sulfur, this one's a sulfur, this one's a nitrogen, this is a sulfur. You can tell by the color and size that they're different. All we have to know is they're different. So that's a mixture of elements, and they're not chemically connected at all. If they were chemically connected, they would become compounds, right? So here we have some molecules. So here is molecules and atoms. So individual atoms, this is a molecule of an element. Okay, molecules of an element. Let's say these are hydrogens. Okay, all of these, this would be written in chemical formula form as H2. And then these green ones we said were nitrogen, so these are nitrogen. So we have a molecule and a single atom. Here we have molecules of different elements. So let's say, again, we have the hydrogens here. And let's make the little pink ones, let's call those CLs. Okay, Cl, Cl. So this is H2 and Cl. Again, the models that we have come with colors and directions. And here we have molecules. So a Cl molecule, Cl2, and then we've got an H2O molecule here. But this is a compound. H2O is a compound because they're two different, at least two different elements. Cl2 is two of the same, so molecule and a compound. And here is all molecules. Okay, so let's take a look and see how we do here. Okay, so who can write in here? Let's take a look. Which one of these is, right, a molecule? Okay, an element that's a molecule. Can anybody write in there? Won't let you drag. Okay. How about somebody want to write in which one of these there's a molecule? All right, Kamaya, let's get you there. Every time I turn a slide over, it takes you out. So just write the letter E for element. Okay, so let me give you whiteboard access. Here's what we're looking for. Okay, here is a molecule of an element. A molecule of an element. Okay, theirs shows a little bit different. Okay, right, this shows a little bit different than theirs. Theirs are put together. So which one of there's a couple of them in there that are molecules of an element. Okay, so which one would you pick? So you can put the letter E anywhere you go. You got, that's right. That's one right there. Letter E. Yep. Yep. So you might want to go to the styles up here, Kamaya. If you click on the styles, it'll go to a larger one, and then you can make a larger letter in there. All right, there you go. Excellent. So yeah, here is an element of hydrogen comes in 2, H2 hydrogen. Okay. Anybody want to pick out another molecule in here? This one looks like this one right here. There's another molecule. Anybody want to pick out another molecule in there? Put the letter E for element. Looks like you got it right, Kamaya. Go ahead. Nobody else is saying they want to do it. I appreciate you doing that. Yeah. Okay, how about this one? Anybody want to do this one? This is H2O. This is a compound. Anybody want to try this one? Put down C for compound in here. Okay, Kalia, thanks for offering to do that. Here you go. Where is H2O? Where is H2O compound? And if you go to the styles over here, you can click on large style and that'll help you get there. There you go. That's a compound. And then this last one is, okay, this one is also a compound. And it looks like this. It looks kind of like it looks like a carbon, which is black here. That's how my model goes. And then we have an oxygen attached to it. And then we have to put, oh, here we go, another bonding unit. And then we have another one. So this would be the last one. If you do that, Kalia, if you put down C for that last one, so this is carbon and 2 oxygens. Oops, can't see it. Carbon and 2 oxygens. There you go. Thanks so much. Excellent, excellent. All right, so let's see if we can figure out these here, okay? All right, so we're going to do a poll in this particular case. So we're going to skip the first one. We're going to go to 2. Which is the above picture represents molecules of an element? Okay, so let's do this poll. Let me clear the chat here. Start a poll. Okay, molecules of an element. Okay, so molecules of an element. All right, so this is going to be A, B, C, and D. Okay, so we're going to do this one. All right, so molecules of an element. So I'm going to show you this one, help you out here. So it looks like this. Several of these. Which one of those is a molecule of an element? Remember, the same color, bonded together, molecules of an element. Okay, right? Now, letter C looks like this. Letter C looks something like this. 2 atoms, different colors. We're looking for molecules that look like this. Which one of those shows, think about the strings pulled, tighter together, okay? Which one? All right, I'm getting some. Got 2 and 2, 4 people out of 11. All right, anybody see this in that one? All right, so 3 of you guys have gotten it. Thanks so much, Kamaya and Rihanna, Soraya, Bradley, and Christian. So it is actually letter A. Okay, if you can see that, there are 3 of those. 3 of those bonded together. That's a molecule, and because they're the same color, they're an element, right? Okay, let's do the next one. Okay, so let's do which displays, start a poll, a mixture of atoms. Okay, still mixture of atoms. Again, this takes a lot, some practice on your part. Okay, thanks for getting in there. So we're going to do B, C, or D. B, C, or D. All right, going to take that off. Which one is it? A mixture, and we're looking for something that looks like this. They're single atoms, different color. Which ones would that be? B, C, or D? Mixture, 2 different colors, single atoms. Which one would that be? All right. Thanks, Shayana and Phoebe and Bradley. All right. And yeah, you guys got it. Yeah, it's letter C. Right. Letter C, mixture. Okay. All right. Let's go to another one. And we're going to use the next line here. All right. Let me get this going here. Let me get that out of the way. Okay, 2 poll questions. Okay. All right, so in letter E through F, I'm going to ask you a question. Which picture displays molecules of a compound? Molecules of a compound. Molecules of a compound. Molecules of a compound. And we're going to do E. All right, so E, F, G, and H. Okay. All right, so E, F, G, and H. Let's see how we do on this one. Okay, so we're looking for something that has 2 different colors attached together. Okay. Molecules of a compound. Just molecules of a compound. Okay. Which one do you think? All right. So people that have chosen F have this, and then they have this. Okay. So this is not a compound. This is a compound, right? This is not a compound. This is a molecule. This is also a molecule, but it's a compound. Which one of these shows a molecule of a compound, right? For letter G, what you're seeing is this and this. So you have a molecule and a single atom. For letter G, molecule and a single atom. All right. Okay. So the correct answer here is letter E. So letter E looks like this. Just 2 elements, different color, black and red. Okay. And they're all the same. Those are all the same compound. Okay. Letter E has a compound that's different. So letter E looks like this and this. Okay. It is one of these and then one of these. Plus it has a molecule. So it's got 3 different things in there. Okay. All right. So let's practice this. Okay. So I want to try this out for you guys. Let me give you a, all right. So we're going to try this word wall. Turn my screen off here. Okay. And word wall, we're going to try this one here. Okay, so let's try to match these, okay? Okay, so I'm going to turn this poll off. Okay, there you go. All right, give that a try and tell me how you do. Okay? Right? And I will, once I'll give you like 3 minutes. Oh, I think we ran out of time, didn't we? 2:45. We did. Okay. All right, I'll let you guys go and then we'll go over these tomorrow. Thanks so much, guys. I apologize. We ran out of time here.